All right, happy Monday. Today we are looking at characteristics of graphs of quadratics specifically, but these are our interactive notes, so we're going to fill them out together. So, interval notation represents an interval as a pair of numbers. The numbers are the endpoints of the interval. So, like start and stop points. You will either use parentheses and or brackets. Sometimes you use one of each, sometimes you use one or the other to show how things are excluded or included. So regular parentheses or brackets. So we have two different types of intervals with the parentheses and the brackets. So when you have brackets, this means that you include the number. So if I had an inequality, I would use that for greater than or equal to or less than or equal to. Excuse me. Oh, that's not nice. All right, so for my parentheses, you will use these when you don't include the number. This would be like if I had the inequality greater than or the inequality less than. Alright, so domain are the x values that are contained in the graph. We always write from left to right. The range are the y values that are contained in the graph, and we write them from bottom to top. So there are three examples. One of them is a quadratic, the other ones are just some other functions, but we're just going to look at the examples. So domain, when I write them from left to right, so I'm going to look as far left as I need to go for my graph. So it goes from -3 to +3. So my x's go from -3 to +3. So those are the numbers I'm going to use for my intervals. -3 on the left, +3 on the right. And since I have a closed circle here and I'm using it, I'm going to use a bracket. Same for the +3, it's a closed circle and I'm using it, so I use a bracket. For my range, my y values, I want to go from top to bottom. So this is the highest point on the graph. This is the lowest point on the graph. So I want to go from +2 to -4. But when I write my interval, I always want to go low value to high value. So the lowest is always on the left. The highest is on the right. And I'm going to use brackets to represent because I'm using those values. All right, so for the second example, looking for my domain, from the left, I go from -2 to the right to +5. So from -2 all the way to +5, but I am not using the +5. Closed circle at the -2, open circle at the 5. So closed circle at the -2 with a bracket, open circle at the 5, so I use a parenthesis. For my range, going top to bottom, my lowest value is -3, and my highest value is at a 1. I am not using the -3, so that's going to be an open parenthesis at the -3. I am using the 1. All of these represent closed circles at the 1. So low to high, I use a bracket. Number 3, we have a parabola like we talked about on Friday. I'm going to stick some arrows on here because it's going to continue on. So for my domain, this graph is going to continue to go up and to the left until I run out of paper. And then it's going to continue to go up and to the right until I run out of paper. So like we talked about on Friday, the domain for every quadratic will always go from negative infinity to positive infinity. For every quadratic, you'll have negative infinity to positive infinity for the domain. It's not going to actually hit infinity, so I use the parentheses. For my range, this is the lowest that my graph is going to go. And then it's going to go up and never stop going up. So -2 is my lowest value, and my highest value will be positive infinity. I'm not going to hit the positive infinity, but this is an actual close point on my graph, so it represents a bracket on my range. All right, increase and decrease. We always read increase and decrease from left to right. If your finger is going up on either side, like when you read it from left to right as a book, then the graph is increasing. If your graph is going down as you read it from left to right, then your graph is decreasing. So we have an example here of a parabola. I'm going to put arrows on it. So this graph, if I start on the far left, it is decreasing. When I hit this point, the vertex, I then start increasing. So every parabola has 2 intervals. One will be an increase, one will be a decrease. So this is a decreasing interval until I hit this point, and then I have an increasing interval after I hit that point. That point specifically has an x value of 1. So my negative infinity to 1 is my interval of decrease. So my interval of decrease is negative infinity to 1. Only use parentheses every time you do the intervals of increase and decrease, always. So my decrease, you'll always use one of your infinities, but it's going to stop decreasing at 1. At 1, it's going to start increasing as I read my graph from 1 to the right. So my interval of increase is going to go from 1 to positive infinity. This always cuts the domain in half for a parabola. So if you look, this is the same parabola that we have up here. My domain goes from negative infinity to positive infinity, so that's all numbers. But there's a point on all of my numbers where I switch from increase to decrease. That happens at the number 1. So I'm going to use the number 1 in my interval of increase and decrease. 1 to the right is the increase. 1 to the left is my decrease. All right, so extrema. So a maximum value is the highest point seen in the data or on a graph, and then my minimum value is the lowest point seen on the data or in the graph. So if I look at this example, I don't have a highest point because it's going to continue on for infinity, but I do have a lowest point. So this is my lowest point, which is called my minimum value. So for my extrema, I'm just going to put on here minimum value and then list the coordinate of that point. The coordinate for that point is 1, -2. So for the extrema, tell what it is. Is it a min or a max? And then what is the actual coordinate? The axis of symmetry, like we talked about when we were graphing, is the vertical line that cuts my parabola exactly in half. I can fold it across this line right here. This line is a vertical line at x equals 1 because all my x values along this line are 1. So my axis of symmetry, x equals 1.